Let's talk about liquid 1352 product of the last k numbers. It let us to implement an add method which can add our integer num into our data structure, and also get a product int which there is one parameter k which let us to find the last k numbers products in our data structure. Um, it says that the text keys are generated so that at any time the product of any continuous subsequence of the numbers will fit in a single 32 bits int without overflowing. So this one give us a hint that we can use our number, what we call prefix product, to store all of the when we add a number, when we can multiple equal to this number to the um, prefix product, and will not have worry about the data overflow. Because for the range, it is possible, right? If it is integer and multiple by this kind of times, right? So it is possible to be overflow, but it's give this kind of condition that we can safely use our integer product prefix sum product. And here there is one thing is that if those kind of number there is no zero in it, right? So what we can, of course, we can use the when we have the prefix product, right? And divide by in some kind of prefix product, which is this current and the current minus k, right? If there is no zeros, but if there is zero, some in, for example, in data range, for example, 1, 2, 3, and 0, that means all of this kind of products will be zero. How can we handle this kind of error conditions? So what we do is that we can use a list to store those kind of prefix product, right? So when there is a zero coming, we just clear the prefix product list so that we set our prefix product variable to be one again, right? And um in the so when we get call this get product, we're trying to see this kind of list prefix product list whether it has length greater or equal to k, right? If it is greater or equal to k, then we can safely use the divide calculations. Otherwise, we just return zero, right? Here, if we use a prefix product, we normally add extra value 1 at the beginning for this kind of values to our list, right? No matter if it is prefix sum, we normally add a 0 to the beginning so that we don't need to worry about the length, right? So here, what we are going to write is as long as this kind of length, the prefix product length is greater or equal to k plus 1, right? We can use a divide. We don't need to worry about the if the k is equals to those kind of numbers. The right, so we just use the same formula. Otherwise, if it is smaller than k plus 1, we return 0. So let's write code for this, right? So we need an int product. Let's set this at 1, and we have a list of integer to store any previous prefix product. And we have prefix product equals new array list. And we have prefix product add one, right? So when we add, what we do is that there are two scenarios. If this column is at zero, right? If this is zero, what we're going to do is that we need to have this product clear, right? Clear the contents. And also, we are going to set this product equals to one, right? Else, what we are going to do is we are going to have a product multiple equal to none. And in the end, we need to have prefix product add this kind of num product at this. So here we'll say if prefix product this size is smaller than k plus one, right? Means we don't have enough numbers. There are some or either we didn't have add k numbers, or we there is a zero between in the previous k, right? So what we do is that we're going to just return zero. Here it says that you can always assume the current list has at least k numbers. So that means this size is smaller than k minus one. That means there is a zero before this, right? And if there is no such condition, we should have another we should need to worry about whether this k size smaller is that because we don't have enough number, or there is a zero. So, but when we have this condition, that means that it can only be the possible that there is a zero in the previous k number, right? So, and else what we return is just a return we have int for example int number, right? Equals prefix product dot size minus one, and just return prefix product get y divided by prefix product get y minus k, right? Not y, m. So for this kind of add and get product operation, that is O1 time complexity. And the space, right? It may have some kind of, this will be linear. Worst will be ON. And the Python code is very similar. Let's also write the Python code. We need for example self dot prefix product equals this one, right? So, and we need a self dot product equals one. So when we add, what we do is that if this num equals zero, right, then we're going to have self dot prefix product. Set this one as this again, right? And self dot product equals one. Else we're going to have a self dot product add multiply equal by none, and self dot prefix product should append this kind of product, self.product. So when we have get is if length, right, length of self dot prefix product is smaller equal to k, then we return 0. Otherwise, we return self dot prefix product minus 1 divided by self dot prefix product minus 1 minus k, right? Prefix product